In this video, we're going to talk about angles formed by parallel lines, which was the major topic that you learned in geometry this past week. We're going to talk about the different angle relationships that are formed when parallel lines are cut by a transversal and how to solve problems using these angle relationships. So first we have a theorem here. If coplanar lines are not parallel lines, then they are intersecting. So basically, if two lines are not parallel, then they intersect. Notice here we have a picture of line AB and line CD, and we can see that they intersect, they meet, they touch, they're not parallel. We have a special case of two lines that intersect and form right angles. You might have already heard the word for that, perpendicular. When two lines intersect and form right angles, we call these lines perpendicular. So I can draw you an example of perpendicular lines. Two lines that intersect to form right angles. Here we have the symbol for parallel. We read this as line AB is parallel to line CD. And here is a picture of parallel lines AB and CD. Notice how they go on forever and will never intersect, they'll never touch, they'll never meet. So think about what are parallel lines. Once again, parallel lines are lines that never touch, never intersect, never meet. What are perpendicular lines? They are lines that intersect to form right angles. Lines that intersect to form right angles. Here are our parallel line theorems. The first one that we have is if we have a point and a line, we can only draw one line that is parallel to the given line that also passes through the given point. So basically, over here, we're starting with a line and a point. And if we wanted to draw a line that was parallel to this line and also passes through this point, the only one we would be able to draw is this one that's dotted over here. This would be the only line through this point that is parallel to this line. If a line intersects one of two parallel lines, it intersects the other. As you can see here, line EF intersects one of the two parallel lines AB, so it also has to intersect the other parallel line CD. And finally, if two lines are perpendicular to the same line, then they are parallel. Notice how line CF and line DE are both perpendicular to AB. They form right angles with it. Since they are perpendicular to the same line, they are parallel. I'm going to write that over here. Line CF is perpendicular to line AB, and line DE is also perpendicular to line AB. So line CF is parallel to line DE. Once again, if two lines are perpendicular to the same line, then they are parallel to each other. Here we have a new definition, transversal. A transversal is just a line that intersects two other lines. So if we take a look at this first question over here, and we want to identify what the transversal is, we see that the transversal is the line that's in red. That is the line that is intersecting the two other lines. Notice that the lines that it's intersecting are not parallel. They don't have to be. The definition of transversal is just a line that intersects two other lines. the transversal over here would be this line that I'm outlining in green. It is a line that intersects two other lines. Two intersection points. One intersection point on one line, the other intersection point on the other line. Over here, I see that this line is definitely a transversal. It hits the top line and it also hits the bottom line. And I see that this line here is also a transversal. It hits the top line and it also hits the bottom line. When we have lines cut by a transversal, some angle relationships are formed. The first one that we're going to talk about is alternate interior angles. The definition of alternate interior angles is a pair of interior angles on opposite sides of the transversal, not sharing a common vertex. So basically, interior means inside the lines. So inside the lines would be interior, not outside the lines. Alternate interior means on different sides of the transversal. So if one is on the left of the transversal, the angle that would be alternate interior with it would be to the right of the transversal. If I'm talking about this angle on the right of the transversal, the angle alternate interior to it would be this one on the left of the transversal. Alternate exterior angles. I'll draw you another picture. So exterior angles are outside the lines. So here are the lines. Inside the lines would be interior. Outside the lines are exterior angles. So alternate exterior angles would be outside the lines on different sides of the transversal. So if this exterior angle is to the left of the transversal, the angle alternate interior to it would be on the right of the transversal. If this exterior angle is to the right of the transversal, the angle alternate exterior with it would be to the left of the transversal. Consecutive or same side interior angles. These are a pair of interior angles on the same side of the transversal. So let me draw you a picture of that. Once again, interior means inside the lines. So here are our lines. So interior angles are located within our lines. Same side interior angles are on the same side of the transversal. So if this is one of our interior angles, the one that's same side with it would be to the left of the transversal as well. If we're talking about the interior angle to the right, the one that's same side or consecutive interior with it would be this one here that's also to the right. And corresponding angles. Let me draw an arrow. I'm going to make the diagram here. Corresponding angles are a pair of angles on the same side of the transversal, not sharing a common vertex. I like to think of corresponding angles as in the same position where the lines meet the transversal. So here, where the lines meet the transversal, we have top left, top right, and bottom right. So let's start with top left. Here, where this line meets the transversal, we also have a top left. Same position. Bottom left. Over here, we also have a bottom left. Top right. Here we also have a top right. And finally, bottom right would be corresponding to bottom right over here. So angles that are in the same position. where the lines meet the transversal. So let's label one pair of angles for each of the types listed. So corresponding angles, there's a lot of different options. I'm going to go with bottom right, bottom right. And see if, while you're watching this video, you can also figure out where another pair of these angles would be. Alternate interior angles. I need orange for that. So interior would be inside the lines. So inside the lines, let's go with this interior angle. The alternate one from it would be, since this is to the left of the transversal, would be to the right of the transversal. Vertical angles, I'll just go with this angle that we already identified as alternate interior with this one. It would be vertical to this angle. Remember, vertical angles are formed by intersecting lines. They come out of the same point and they're non-adjacent to each other. So here we have vertical angles. They look like they're across or opposite from each other. Same side interior. Here's an interior angle. Here's the interior angle on the same side of the transversal as it. And finally, alternate exterior. I'll just go with this exterior angle. And its alternate exterior with this exterior angle because they're on different sides of the transversal, both outside of the lines. So we have some theorems about the relationships between the angles formed by parallel lines. So if angles in the diagram are congruent or supplementary, that could make the lines parallel. Let's see which of these theorems say that. So if two lines are cut by a transversal and the alternate interior angles are congruent, that makes the lines parallel. So, for example, if angles 1 and 2 here, if we know that they're parallel, since they are alternate interior, they're inside the lines on different sides of the transversal, that would show that the lines are parallel if that relationship is there. If two lines are cut by a transversal and the corresponding angles are congruent, that is a different reason that would also make the lines parallel. So for example, over here in this diagram, 3 and 4 are corresponding angles, bottom right, bottom right. So if we knew that they were congruent to each other, if we knew they were the same, that would be enough to show that lines A and C were parallel to each other. And finally, if two lines are cut by a transversal and the same side interior angles are supplementary, that makes the lines parallel. So here, angles 3 and 2 are same side interior angles. They're both on the same side of the transversal inside the lines. And if they add up to 180, let's say 3 was 120 and 2 is 60. If that's true, if they add up to 180 degrees, they're supplementary, that's enough to also show the lines are parallel. So just like these theorems can show that lines are parallel, if we already know the lines are parallel, then we know that these relationships hold and are true. Here is a diagram that shows the angle relationships that we talked about. Remember, when parallel lines are cut by a transversal, corresponding alternate interior and alternate exterior angle pairs are all congruent. Once again, we need to know that we have parallel lines cut by a transversal in order to know that those relationships are true. Additionally, same side interior and same side exterior angle pairs will add to 180 degrees when parallel lines are cut by a transversal. So all of these relationships are only true when we know that the lines are parallel. The only relationship that holds no matter what, even if the lines are not parallel, are vertical angles. Vertical angles are always congruent no matter what, even if the lines are not parallel. For each example, find the value of the variable. State the angle relationship that justifies your answer. A and the 48-degree angle are corresponding angles. Top right, top right. Corresponding angles are congruent when parallel lines are cut by a transversal. We know that we have parallel lines here because I see the little arrows on the lines. Those little arrows indicate that they're parallel. So A should also be 48 degrees, once again, because they are corresponding angles. Here, B and the 48-degree angle are same side interior angles. They're both inside the lines, the parallel lines. Notice the arrows, and they're both to the right of the transversal. So they should make 180 degrees. So 180 minus 48 will give us the value of B. And 180 minus 48 is 132. Once again, that's because they are same side interior angles. And in the first example, we had corresponding angles. Here, we have inside the lines on different sides of the transversal. So they're alternate interior angles, which are congruent when parallel lines are cut by a transversal. Alternate interior angles. And finally, D and 48 are exterior angles outside of the lines on different sides of the transversal. So they are alternate exterior angles, which are congruent when parallel lines are cut by a transversal. If angle L is 35 degrees, we can use our angle relationships to find the rest of the angle measurements. I know that angle L and angle I are corresponding. This is top right. That's also top right. They're in the same position. I know that vertical angles are always congruent. So K is vertical to I, N is vertical to L. I know that any two angles right next to each other are supplementary. So angle O and angle L are supplementary. So 180 minus 35 is 145. And O is vertical to M, so they're congruent. O and J are alternate interior angles inside the lines, different sides of the transversals, so they're congruent. And finally, this is vertical with H, so they are congruent as well. Let's find the value of the variables in each of the diagrams. So in this top one, we have parallel lines cut by a transversal. Oops, I highlighted that really badly. So I see that these two angles here are alternate exterior angles outside the lines, different sides of the transversal. So since we do have parallel lines cut by a transversal, they are congruent. So I'm going to set them equal to each other to find the value of the variable y. So let me subtract 27 from both sides. I got 98, and then dividing by 7. I got 14. I do also know that any two angles next to each other form a linear pair or supplementary. So I know 15x minus 5 and the 125-degree angle need to add up to make 180. Combining my like terms, I have 15x plus 120 is equal to 180. Subtracting 120 from both sides, I have 15x equals to 60. And then dividing 15 on both sides, I have x is equal to 4. So in the first one, we have now found both of the missing variables. Let's move on to the next one. In the next one, we have parallel lines cut by transversals. And the first thing I notice is that these two angles here are same side interior angles. They're inside the parallel lines, both to the right of the transversal. So I know that they add up to 180 degrees. They're supplementary. So 180 minus 106 is 74. So I know that x is 74 degrees. I also know that the x angle and this angle over here are vertical angles. Notice how they come out of the same point? They're formed by intersecting lines and they look like they're across from each other. So they're congruent. If x was 74, this angle over here is 74 degrees as well. And if I take a look here, this angle and the 74-degree angle are same side interior angles. They're inside the parallel lines, both on the same side of the transversal. So I know that they're supplementary. So I could make the equation 4z plus 6 plus the 74-degree angle equals to 180 degrees. Combining my like terms, 4z plus 80 equals to 180. Subtracting 80 on both sides, 4z is equal to 100. And dividing by 4 on both sides, z is equal to 25. Only one more variable to find, y. And I see that the 106-degree angle and the 2y angle are supplementary. So I can make one more equation that says the 106-degree angle and the 2y angle together need to make 180. Subtracting 106 from both sides, we have 2y is equal to 74. And then dividing by 2, y is equal to 37. We have found all of the missing variables in this example. In this last example, we need to find x. Even though there are 3 parallel lines here, we only need to focus on the ones that have the angles that we're interested in. So this parallel line is forming this angle. This parallel line is forming that angle. So I noticed that the 50 and the 2x plus 8 are exterior angles. They're outside of the parallel lines. And they're alternate, different sides of the transversal. This to the left, this to the right. So alternate exterior angles are congruent when parallel lines are cut by a transversal. So I'm going to make the equation 50 is equal to 2x plus 8. Subtracting 8 on both sides, I have 42 is equal to 2x. And then finally dividing by 2 on both sides, I have x is equal to 21. Last slide for this video. Find the values of x, y, and z that make line P parallel to line Q and that make line Q parallel to line R. Explain your reasoning. So first, let's focus on the first one, showing that P is parallel to Q, finding the values that make P parallel to Q. Here's P, here's Q. The two angles that we have information about, 3 parentheses x minus 1 and 4x minus 30, are alternate exterior angles. Notice how they're outside of the lines on different sides of the transversal. Now we don't know P is parallel to Q, but if it were, we would know that alternate exterior angles are congruent when parallel lines are cut by a transversal. Since we want the value of x that would make the lines parallel, let's set these alternate exterior angles equal to each other to find the x value that makes them equal, that will make the lines parallel. 3x minus 1 is equal to 4x minus 30. Let me distribute the 3 inside the parentheses. Let me add 3 to both sides. Subtracting 4x from both sides. And we have x is equal to 27. We also need the values of x, y, and z that make Q parallel to R. So for a second, I'm going to focus on Q and R to see if I see any more angle relationships here. And I do notice that the 4x minus 30 degree angle from before and the 6y degree angle are corresponding angles. Bottom left, bottom left. If the lines were parallel, then the corresponding angles would be congruent because corresponding angles are congruent when parallel lines are cut by a transversal. Since we don't know the lines are parallel, we can assume that. But since we want the values of the variables that make the lines parallel to each other, let's find the value of the variables that would make these angles equal to make the lines parallel. So where 4x minus 30 would be equal to 6y. Oh no, we have two different variables in this equation. We already know what our x value is. We found it before. So let's substitute in 27 for our x value. And then all we need to solve for is y. 4 times 27 is 108. 108 minus 30 is 78. And then dividing by 6, we have y is equal to 13. We only have one more value to find, and that's the value of z. Let me highlight P and R. Notice how the 3x minus 1 angle from the beginning and the 6z plus 8 angle are corresponding angles formed by lines P and lines R. Oops, backtrack, I highlighted that incorrect. My bad. Let me highlight again the 3x minus 1 degree angle and the 6y degree angle. Notice how these are alternate exterior angles formed by lines P and R. They're both exterior angles because they're outside of the lines P and R, and they're on different sides of the transversal. This is to the left, this one's to the right. So once again, if we had known that the lines were parallel, the alternate exterior angles would be congruent because alternate exterior angles are congruent when parallel lines are cut by a transversal. Since we want to show the lines are parallel, let's make these angles equal to each other to see what the values of the variables would be to make the lines parallel. So once again, I'm going to take the 3x minus 1 and equal it to 6y. We already know what our value of x is, so I'm going to plug that in. Let me multiply the 26 by 3. And we found that y is equal to 13 like before. To find the value of z, I know that these two are supplementary. So I'm just going to set up an equation that adds them together and equals them to 180. We know that y is 13, so I'm going to plug that in for y. I'm going to distribute the 6. Combine our like terms. 6 times 13 plus 48 is 126. So we have 6z plus 126 equals to 180. 180 minus 126 is 54. And then we have z is equal to 9. So we found the values that all the variables need to be to make the lines parallel to each other. Part B says, would P be parallel to R? Well, we know that if lines are parallel, the alternate exterior angles would be congruent. That would be one thing that would happen if lines are parallel. We found our x value is 27. So this angle over here would be 3 times 26. And 3 times 26 is 78. We know that y is 13. We found that. 6 times 13 for this angle over here would also be 78. So yes, with the values that we found, the line would be parallel because the alternate exterior angles are congruent, showing that lines P and R are parallel to each other.